Well, it's great to have a chance to present this paper and to be here with all of you. I want to thank Lee and Adam and Philippe for including this and also for doing all of the work here and with your colleagues as well, Olympia and Patricia. This is a great conference. Very interesting to be part of it, and it's a pleasure. So, and Adam, thank you for double duty for also discussing this. All right, so this is joint work with Ryan Hill, my colleague at Northwestern, Yan Yin, who's a computer scientist at Cornell, Carolyn Stein, who is at Berkeley, Zhizhao Wang, who's a graduate student at Northwestern, and Daxun Wang, who's a close collaborator at Northwestern as well. The title was Adaptability and the Pivot Penalty in Science and Technology, and in the spirit of Zvi Griliches, I think it is about measurement and then what you might do with the measurement at scale. And so hopefully this will, although I unfortunately started my PhD the year that, in the fall, that Zvi passed. I never had the chance to know him. I definitely have come to appreciate through all the people who've taught me and who did know him how much my research has been affected by the kind of ideas and the values that I think he brought to us all. Okay, so, all right, so what is the question here before we get to the measurement? So something general, and I hope this will be of interest not just as about science as a whole and science policy, but to you individually, is that, the world of knowledge is changing all the time. People are writing new papers that we might want to interact with, and then new things are happening in the world, like the rise of artificial intelligence or the pandemic, and we might think we might want to use or address. So at a personal level, we're trying to adjust to new challenges or opportunities. But then also we probably think that the adaptability to threats and opportunities as they emerge is central to the survivability of certainly businesses. This is a longstanding question in business about why leading businesses fail and fail to adapt to new technologies, but also to what economies and societies as a whole with things like, say, the pandemic in mind. And so kind of at the root of this, we might think that sort of R&D workers and researchers are important to adaptability, but we don't necessarily know that much about how well we can adapt to new things. I think one of the lenses from the literature on this question is the explore versus exploit sort of orientation in creative search, which is goes back to March and is very, very big in economics of organizations and in management. Thinking about, notionally exploit would be to kind of keep doing what you know how to do and just kind of maybe more micro innovations, whereas explore would be to jump into new territory, which of course might be higher risk, but maybe also higher reward. And related to that are ideas and creativity, many, but including ones such as, maybe the big ideas, the truly transformative ideas in areas really come from outsiders. This is something that you see in like entrepreneurship, for example, and that people with really fresh ideas aren't necessarily beholden to the paradigm that is really set in within a particular specialty. So you might think different things about how things might go when you explore versus exploit. And so that's really the question we're going to try to answer is, what happens when a researcher at an individual level or part of a collaboration moves to a new area of study. We're going to have papers and patents, though I'm going to talk just about papers, which is the major emphasis of the paper today, given the limited time. Maybe a few shout-outs to patents, or maybe Adam will as well. Again, the approach, as I alluded to, it's really just a measurement framework for researcher pivots, and one might come up with many measurement frameworks for this, so there's no sense of optimality here, but just we kind of came up with a measurement framework that seemed like it might be one way to measure how individuals change directions or move into new places, and then we kind of take it out for a spin, that's the second bullet, and we're going to sort of, in our mind, investigate what happens at scale, and we're going to kind of come across a fact that's going to seem to be pretty durable and robust across fields, contexts, et cetera, which I'll show you in a minute. And then we've done some more with evidence from shocks, including applications to pandemic-targeted research, which is actually where we started, by the way. So we started writing this paper in the pandemic. It's been kind of an ultra-marathon paper. There's a lot to it at this point. But we were interested, all these people we knew, including ourselves, were sort of putting our toe in the pond, trying to be useful. This challenge, the pandemic has come, and but we're like, could we have anything useful to say? It's kind of one of the questions we were trying to analyze even from the beginning. So the main data sets is journal articles, lots of journal articles, dimensions, which I think was what Kareem was using as well, and then patents. That's less than the number of patents that appear in that time frame, but we need people who have had multiple patents because we need to see how this is all about synthetic CVs and watching how someone shifts direction compared to themselves. So we have, in general, think of this as people who produce quite a few patents are quite a few papers, not people who just appear once. All right, so to start with measurement, I'll give this to you twice. Here's the sort of mathematical description. Really, this is just cosine similarity, so nothing really fancy. But what we're going to do is take a researcher I in a paper J, say. It could be an inventor with a patent, but take a paper. They're going to have a vector. Okay, so take the focal paper J. They've just produced this paper, and in it there's a reference list to the things they cite. And we're going to say, okay, those references we're going to code. We're going to code them by the journals that are cited. So this is going to be a vector of the journals that are being cited. So if you cited the AAR 3 times, you'd have a 3 for the AAR. And if you didn't cite, Physics Review E, you'd have a 0 in that vector for Physics Review E. And then RI is then the union from your prior work of the references that you've cited. So put all the kind of things, all the journals you've cited normally, okay? And then we're going to look at the cosine similarity between the current paper J and what you normally have done on average, right? And that's going to tell us, are you kind of citing the same distribution of journals that you usually do, i.e. you don't seem to have moved too far, versus you're citing a very different set of journals, which we're going to call a pivot for our purposes. And so that's the actual measure, just a cosine similarity measure. To show this pictographically, so we're taking the union of a given author's prior works, and each one of them has references, which we've color-coded. You take the union here of all of those references by journal. We also do it by field if you want. You could do this lots of different ways. You could do keywords, but we're doing it by journals in the main paper. And then here are a couple of new papers, and we're going to look at the journal references in that new paper and look, you can see from the color scheme that these are a very similar distribution of journals. That's going to have a low pivot, close to 0, and then if you did a very different set of journals by different color scheme, you're going to have a very high pivot. Right, so the pivot measure is going to be 0, means you're doing exactly what you always do, and 1 at the maximum would be actually it's a completely orthogonal set of journals. The journals you're citing, you've never cited before. That's how you get to a 1, okay? Makes sense, and so it creates a 0 to 1 measure, which is sort of very simple. Okay, so this is for papers, the distribution. We're taking papers in 2020, that's in blue, and you can see from 0 to 1, you have quite a wide spread, so you get kind of a lot of variation in a fairly smooth way using this pivot measure. And just to give you some sense of what it's measuring, if you take COVID papers, these are papers with COVID keywords in 2020, you see they're much shifted to higher pivot size. So people who wrote COVID papers are typically jumping much further from their prior work than they are in their normal distribution. Okay? All right. And then you can do this for patents. For patents, it's actually a bit more bimodal, so it's kind of interesting. People seem to sort of stick with one thing or maybe jump to the end of the other spectrum. We've investigated that way. Investigated in many ways. It seems like just true about patents. I think what might be going on there is that because inventors work in firms, they tend to be allocated as opposed to choosing. And so maybe they're like, you keep working on exploiting this thing, or you guys are now going to go try this new thing over there. And so they're being sort of moving around maybe more than we see in people like us who write papers. But anyway, okay. All right, so that's the measure, and then we're going to kind of take it out for a spin. And the first thing is just to relate it to impact. So I'll just show you. Maybe you can think for a second if you haven't read this paper. Like, what do you think we'll find? Where are you going to peak in impact? Is it when you're closer to 0, closer to 1, somewhere in the middle? Okay. All right, here we go. So now you can judge against your prior. So this is why we call the paper the pivot penalty, because the further you pivot, on average, the worse it goes. Now, the measure here is, these are papers. The measure is 0-1. Are you in the upper 5 percentile of citations received for papers in your field in that same publication year? So that creates a normalization across time and field. So you kind of, every field is 5% chance of a home run, basically, which are somewhat rare. And we're kind of intentionally, partly because we're thinking of explore versus exploit. With explore, you're looking for more kind of bigger impact things. And so we're going to kind of emphasize these higher upper tail outcomes. And you're going to see a pretty big, so this is by construction, if there was no effect, it'd be all at 0.05, right? But you can see at low pivot size, it's more closer to 0.75, and at very high pivot size, it's down like 0.02. So high pivot work is very rarely associated, but it still happens, with sort of home run-like citation behavior. You see the same thing in patenting, more or less. I'm not normalizing in this is just raw data. I'm not normalizing by your own personal hit rate, but if I do this with individual fixed effects, it'll attenuate the slope slightly, but it's still very steep within individuals. And then you can do this outcome measure. I could take 99th percentile citations or really high citations. You're going to find something similar. It's going to be hard to find in the upper tail, like exploration, does have an advantage at some, the higher I go, the worse it gets in a way. But also I could do like average citations and things that are smoother, and you're going to find the same effect. So there's nothing, this seems very robust in that sense. Okay, so then the other related fact is that it's getting steeper with time. So if this is papers, the 70s is in blue, the 1990s is in green, and the 2010s is in red, and you can see that it's getting steeper. You know, in the paper in the new paper we're working on, revising, we explore kind of what's going on underneath these pivot penalties, and we can talk about that maybe more in the discussion, but I'm not going to really get into it here. But you know, one sort of leading hypothesis is part of what's going on, maybe that people are becoming more specialized, right? It's kind of harder to pivot now than it used to be, suggesting that we are in fact kind of increasingly trapped in our main areas of expertise, which, you know, I might not surprisingly relate to the burden of knowledge, but maybe you disagree with me. Okay, all right, so those are the main facts, and it's also getting steeper in patenting, so you could see it there as well. So we also, you know, we see it in kind of different research contexts. You can do it by field. The vast majority of fields, it's all downward sloping, the pivot penalty, and it's getting steeper. We've also looked at other outcome measures outside of kind of citations. So for example, you could take the, you know, market value, event study value of a patent when it's released in a public firm, which of course is only a subset of patents, but we also see a pivot penalty, so the market values appear lower. And kind of Dimitris Papanikolaou, my colleague and his co-author's work. A paper that has a low pivot is more highly likely to be cited in a patent, and high pivot papers are less likely to be cited in a patent. So you have other kinds of maybe impact measures that seem to, you know, also, you know, could be called a pivot penalty. Okay, all right, so that's sort of descriptive, sort of where we started and stopped initially, but then we have thought, and we'll come to COVID, but we thought more also about, you know, can we come up with kind of quasi-experimental evidence? I mean, of course, this is interesting because, like, so why are we pivoting? So, like, we're economists, we're optimizing, so if it doesn't go very well, why are we doing this? So we can come back and discuss that as well. And maybe Adam wants to talk about that, but I'll see if there are questions. We've thought about that, but it's a little bit beyond our scope. But we can also look for more quasi-experimental evidence with kind of treatment and control groups. And so we've done this a couple of ways. We have kind of push experiments. Now you're going to respond to something that's changed in the knowledge environment. It's going to push you out of an area. And then we're going to have a pull experiment. The pull experiment is COVID. You get pulled into COVID, to trying to address this issue. The push experiments we're going to have, or I'll show you here, are when there's replication failure or papers are retracted. Okay? So the idea here is that the replication part is just in psychology. So we take this landmark study in 2015 where something like 100 papers in top journals, people attempted to replicate them in a big collective. You may know this experiment, and they failed to replicate 66 of the 100 papers, or at least at the table they tried to replicate. That was a watershed moment in psychology in terms of changing behavior and getting away from so-called p-hacking or whatever. But anyway, so we have people, the idea here is that the paper seemed like it was true, and then they were all published in 2008, and then in 2015, 66 of them are revealed as non-replicating. And so you could have people who were citing these papers in the interim up to 2015, and then it's like, oh, that's probably not reliable. Okay. Similarly, with retraction, a paper gets published, people are building on it, they're citing it, and then later it gets retracted. So kind of the shock event is the date of replication failure or retraction. A treated person is someone who is not an author of the retraction or a replication, but they were building on it, they were citing it. And then the control group would be people who were citing other papers in the same journal years as the retracted paper, say a non-replicated paper, but not the one, and then otherwise match in some kind of course and exact matching with the treatment. So this is a work in progress actually for this revision, but this is just kind of an event study picture for the retractions, which are the much higher scale. We have like 15,000 retractions we're looking at here. So you've got, pivot size goes up for the treated authors, and then the hit rate goes down, which is at least consistent. Maybe we have other interpretations for this, but it's consistent with, again, with the pivot penalty. But then let me switch to this one, which is COVID-19. How much time do I have here?
You have, let me see, you have 5 minutes,
okay.
6 minutes.
6 minutes, all right, I'll try to use them efficiently. Okay, so the first thing is that people really did pivot. Okay, so you can do it like in every field, all COVID papers are higher pivot than in the ordinary papers in 2020, and et cetera, et cetera. This is like in some sense, a quasi-control set. This is not really a natural experiment because we elected to write COVID papers or not. It's not like you're being exogenously pushed. Nonetheless, you could say, so compare COVID authors and non-COVID authors in 2020, and the red is the COVID authors. You can see that not only pivoted enormously to write their COVID paper, that's the one up there, but it's actually much more than their other papers in 2020 that are not COVID. Right? So it's something unusual in people pivoting to engage COVID-19. By the way, it's all over science and social science. It's infectious disease, like 10%, 11% of papers in 2020, but it's a big percentage of economics papers. It's in tourism and education and legal studies, ethics, all these things that people are talking about it. Okay, so here's the pivot penalty, but with COVID is in red in 2020 and blue is other papers in 2020. And so what's kind of interesting here is, you see it, there's a pivot penalty, so the further you move, the worse it goes, but you also see this impact premium for COVID. So we can begin to think that maybe we pivot and it's hard, but when there's a demand side reason to do so, maybe it's not so bad because we get this compensating differential that, or compensation that people are really interested in that topic. So maybe our first AI papers in economics are not the greatest, but they're still pretty good compared to our other papers. And then of course, the more we do it, maybe we're pivoting less with time because this is the first paper you do. Keep in mind, though, you pivot, if you pivoted one and you continued in that area, the measure of pivoting on your next paper in that sequence would be less than one. Right, because it's going to slowly come back the more you do it. So you're kind of maybe hill climbing in reverse as you maybe become, relatively expert in that domain. Okay, and then we looked at underlying mechanisms. Again, I'm going to leave that aside because I only have such a little amount of time. But we also thought about, but is there a way around this problem? Like, because from a science policy point of view, with COVID or something, we're trying to respond to an emergency. Could we kind of get around it? So looking at kind of the literature, you might think about several things that might think there might be some more flexibility. One would be teamwork, right? So, I may not know how to do that, but if I could just form a team with somebody, then together we could kind of get over to that new area effectively. Another would be funding, and this might in some sense be omitted variable bias if you think that, funding makes your works better, but the more you pivot, the further it is away from your existing agenda, you may not have funding for that. And in fact, we showed that in the data. The higher pivots are less associated with funding than lower pivots. So they might want to say, well, let's control pivot size conditional on having funding for the papers. And the dimensions data, which again, Kareem mentioned, it's very good for this. They track 600 funders from all over the world because they got it from the acknowledgments in the paper. So we know which papers are funded. In fact, you can link it back to the grants in a lot of cases, including the NIH and the NSF. Another one would be career stage, and these creativity models about outsider advantages. It's often kind of a ride-along idea there is that young people in general are more creatively flexible. They could sort of shift across areas where sort of those who have been more seasoned, shall we say, maybe hopefully, but aren't as flexible sort of in our thinking. So you could look by career stage, or you can look at lots of things. So just to show you teamwork, the first one. So this is going to basically take 2020 papers. Blue is non-COVID, red is COVID. Like lighter color means it's a small team, darker color it's a big team, and then over there it's whether it's your usual collaborators or you had a new collaborator. We're just kind of dividing it up to look at, but you can see it's always downward sloping, right? So sort of there are differences in sort of impact depending on how your research, bigger teams, not surprisingly, we know from prior literature, have higher impact, but if the whole team is pivoting, basically on average, it's just going badly. And then you can do the similar thing for kind of everything else I just mentioned on the prior slide, and you're going to find that it's always sort of downward sloping. If you have funding, it's downward sloping. If you don't have funding, it's downward sloping, et cetera. You can cut it various ways. If you control for all sorts of things at once and like lots of fixed effects and a regression, this is what you come up with for kind of COVID and non-COVID papers, for example, in 2020. So that kind of demand-side premium remains, and it's true even with individuals, right? But you still get this downward sloping thing. All right, so my last couple minutes, just to sort of put this in some perspective. So summarizing is kind of a measurement framework with high-scale data to study what happens when researchers enter new areas. Main finding is what we call the pivot penalty. So going back to the kind of creative search literature, it doesn't really seem like big ideas are coming from outsiders. It seems like big ideas are coming from, at least high-impact ideas are coming from insiders. But again, that's going to be true in like market value of patents and not just in these kind of within sociology frame citation behaviors, which might bring in lots of other kind of forces. So we could think, one way to think about it is that there's narrow expertise with time. It's consistent with an impact premium in Pierre and I and Danny, Kim, and Javier Miranda's early work on sort of entrepreneurship in the U.S. and age. We found that it wasn't young people actually, it's older people again. And so some of these things that people think about creativity might not really hold up in high-scale data. And interestingly, while teamwork does predict higher impact, and I think it could extend creative reach, it doesn't overcome the pivot penalty. I should say though, by the way, like if I'm like 100% a one pivot and my co-author's a zero pivot, our average pivot's 0.5. So in some sense, we are getting a benefit, right? But if you're all pivoting, there's nothing magic about teamwork. If you're all pivoting, it's going to go badly, right? So you can sort of work your way back maybe towards lower pivoting by finding experts, but it's not like some magic solution otherwise. In terms of explore versus exploit, explore is often thought of as risk versus reward. This is just like risk. I mean, it does happen that breakthroughs come with high exploratory work, but it's just always heavily penalized, even at the super upper tail of citation impact. So we're not really, so it's just hard, okay? Explore is hard, but you can still justify it with like something really important like COVID-19. Going to the organizational failure literature, this is about the individuals, but of course the individuals are the R&D component within the organization. One way to think about this is that if you're a leading firm in the area and you have these new entrants coming in with new platforms and technologies, and you say, I'm just going to pivot my R&D staff to that might not work out so well, right? Which gets us back into things like acqui-hires. Why is there this rush for talent out of Toronto's AI lab, et cetera? Because you want the insiders. You're trying to pay a lot to get the very best human capital who are already there, and that pivoting your own human capital might be pretty challenging. In terms of science policy, and this is where the COVID experiment I think is interesting because it's sort of society-wide and it's just science-wide. I think the implication is that we got lucky, but you can't pivot people that effectively, right? And so when we often think about trying a wide portfolio of research activities because we don't know where the fruit is going to be found and we want to have kind of uncorrelated bets and all these other things. But the other theme here is that if you get into an emergency, it might be too late, right? So from a kind of risk management point of view as well, having a diversified set of human capital assets who might be in place already. If you go to COVID, like the mRNA vaccine, the spike protein, who were those people? Like the spike protein, that's identified in a University of Texas lab which studies coronaviruses and does structural biology. That's like all they do. They produced a paper in January of 2020, which is the target for the mRNA people who already have the mRNA platforms who can start putting the vaccines in play. That's sort of where the super action was. It was the people who were right there already in terms of responding to the pandemic, and maybe that extends to other things that are more or less emergency-like. Okay, so that's what I had, and I hope that was in time. Thanks.
Yes, that's my standard slide style. Okay. I don't think I really need to do too much of a summary of the paper. Let me just say one thing that was occurring to me as Ben was talking, which isn't in my slides. He didn't really say this, but he kind of moved towards something that the paper doesn't say, which is, he was talking about how there's always a penalty. And that's true, but remember, so what he's saying is that the papers with a really big pivot, instead of having a 5% chance of being in the top 5%, have a 2% chance of being in the top 5%, which of course is a big reduction, but it still means that 2% of them are in the top 5%. So one way to think about this is terrible, but the metaphor that entered my mind was, if you think about like the Allies on D-Day, they threw thousands and thousands of people at Omaha Beach, and most of them were killed, but they took the beach. So I think there is, just be a little careful how you think about it. It is true. What he's basically saying is when things are hard, they're hard. And that's just real. So anyway, but I think the thing to emphasize, he said this, it's across all fields of science and technology, and it's increasing over time. So let me just give you my reaction. I was thinking about this. How often do you read a paper that says something that is very inconsistent with your prior, and yet when you finish the paper, you're convinced, right? Like that doesn't happen very often. So this is really, I think, pretty interesting and astonishing stuff. It's really important. It's important for us as individuals, important for institutions, for funding agencies. I think Zvi would have loved it. It's surprising. It's important. It's data-driven. So then what I'll try to do is I'll try to channel Zvi a little bit and say, okay, so this is really surprising and really important. Are we really sure we understand what's going on here? And what more could we do to understand? So let me talk a little bit about teams. Ben mentioned this. So the way they do it, they're basically looking at the average of the author's previous position and measuring the pivot relative to or you could say it's the sum or the average. It doesn't matter with these distribution vectors. But each individual author has their own position. And I think it would be interesting to think about, he puts in team size, and that diminishes it a little bit, but not very much. But to look more in a more micro way at the structure of the team. Because you'd like to think that you can build a team with complementary skills. And if I'm going to go into a new area that I don't really understand, but I have something to bring to it, I can co-author with someone who really does understand that area, and somehow that ought to work, maybe. And that basically just would require looking in more detail at the structure of the teams in terms of their distance. You know, you could maybe look at the closest team measure. Ben has this other really interesting paper with Mohammed Ahmedpour about on the quality of the member of the teams and the quality of the team as a predictor of the quality of the output. And they have this very provocative result that it's something close to the quality of the team as the quality of the weakest member of the team, which again is sort of really interesting and surprising. So I think what that just says to us is these averages, maybe, you know, there's something interesting below the averages. Or you could think about within team distance as another variable. You have the average pivot, but then also the variance of the positions within the team or something like that. Okay. Then I want to talk a little bit, shift gears and talk about a slightly different issue, which is sort of the context that this falls in, which is, so what we're saying is that when an individual moves to something new, they pay a penalty. But we already know from work by Reinhilde and others that when a paper is far from the typical paper in the field, that there's actually a premium for that. Like on average, papers that move away from the field are more valuable. So this is like pretty interesting here. We've got a reward if you move away from the field, but a penalty when you move personally. And the paper, Ben didn't have time to talk about it. The paper tries to explore this a little bit by breaking down expertise between sort of expertise in the new part and expertise in the base. And I think that is something, he says, what they find is that pivoting researchers are equipped for novelty, but limited in their relevant conventional expertise. And they conjecture that that's sort of the source of the penalty. But I think we could break this down a little bit more. I taught for 3 years at Sloan when I came back from New Zealand, and I've now learned that 2x2 matrices are the way you think about the world. So I constructed a 2x2 matrix. So let's think about...
We're glad we're of service, Adam.
Sorry?
We're glad to have been of service.
Yes, you've helped me pivot. So think about, we could be close, the individual can be close or far, and the paper can be close or far in terms of the field. And what kind of vaguely seems to be the case is we already knew that when you go farther in comparison to the field, you sort of have a higher average impact. But in terms of the individual, holding kind of maybe constant, that field effect, there's a penalty for this movement. And there's something interesting going on there. I think it would be worth thinking a little bit more about how those interact, because they're clearly related, but not in a very simple, straightforward way. And so I think that's something that's just worth thinking about a little bit more. Just as a minor historical note here, I think, I couldn't actually pin this down, I think Zvi was actually the first to suggest this cosine similarity. Back then we called it...
I'm sure you're right, because I think I was there.
Yeah.
You and I were there.
Yeah, and back then we called it angular separation, and somehow later we found out it was the cosine. But then here's the other interesting note. I went back to my 86 paper to try to find if I had said something in the paper about where it came from, and I didn't find that. But I did find this quote, which I found amazing. So I had 500 firms, and I was calculating their pairwise proximity, but I couldn't do it with vectors of dimensionality 300. That was too big for the computer. So I had to reduce the dimensionality of the vectors to 49 categories, or the computer wouldn't calculate the similarities. So it's just and kind of an interesting, that was what, 40 years ago, something like that? Interesting to think about. When we think about the scale of what they did in this paper, it's mind-blowing in terms of the dimensionality of the problem. Okay, just parting thoughts here. I think the way I think about this is science and invention are done by people. What big data, like what Ben and his colleagues have done, is it allows us to have this incredibly powerful lens on the big picture. But I think then we also need to zoom in a little bit to understand what's really going on. Okay, thanks.